Welcome to this session. This session, we are going to solve a problem on determination of whether a set is linearly dependent or linearly independent. So the problem reads, determine whether the set of vectors in R3 given in S1 is linearly independent or linearly dependent. Now, this set, let's call this vector V1, let's call this one V2, let's call this one V3. So our set of interest has 3 vectors. So to test for linear independence or linear dependence, we solve for C1, C2, and C3, the vector equation. C1, V1, C2, V2, C3, V3 equals to 0. And if there are 2 things, one, C1 equals to C2 equals to C3 equals to 0, then S1 is linearly independent. And number 2, if at least C1 or C2 or C3 is non-zero, then S1 is linearly dependent. So that's what you're supposed to do. Now, I'll have C1. My vector V1 is 1, 2, 3, plus C2. My vector V2 is 0, 1, 2, plus C3. My vector V3 is -2, 0, 1. So this will give me a 0 vector, and because we're dealing with vectors in R3, the 0 vector will be 0, 0, 0. So that's what we have from this vector equation. Now let's carry out the multiplication. So we'll have C1, 2C1, 3C1, plus 0C2, C2, 2C2, plus -2C3, 0C3, and then C3. This equals to 0, 0, 0. Then we get a sum on the left. So I'll have C1 plus 0C2 minus 2C3, and then 2C1 plus C2 plus 0C3, 3C1 plus 2C2 plus C3. So this is a sum on the left. Should give us 0 vector on the right. Now, for this equality to make sense, then it means that the first row on the left should be the same as the first row on the right. Second row on the left should agree with second row on the right. And third row on the left should be equivalent to third row on the right. So from that one, we have, this implies C1 plus 0C2 minus 2C3 equals to 0. And then 2C1 plus C2 plus 0C3 equals to 0. And 3C1 plus 2C2 plus C3 equals to 0. So let me call this system 1. Now, you see, system one is simply a homogeneous system of three linear equations and three unknowns, C1, C2, and C3. So to solve this one, let's write the augmented matrix. So we'll have 1, 0, minus 2, 0, 2, 1, 0, 0, 3, 2, 1, 0. So this is what we call the augmented matrix. Now, we now use Gaussian elimination to solve this augmented matrix. So let's just write it. 1, 0, minus 2, 0, 2, 1, 0, 0, 3, 2, 1, 0. It's 1. Now, so we'll say row 1 to be row 1, row 2 will be row 2, plus minus 2 times row 1, so that we enable this position to be 0. Row 3 to be row 3, plus minus 3 row 1, so that I have this position to be 0. This will lead me to, so we have 1, 0, minus 2, 0, 2 plus minus 2 times 1 is 0, 1 plus minus 2 times 0 is 1, 0 plus minus 2 times minus 2 is 4, 0 plus minus 2 times 0 is 4, is 0. This would be 0, 2 plus minus 3 times 0 is 2, 1 plus minus 3 times minus 2, that's minus 3 minus 2 is 6, so 1 plus 6 is 7, and then this will be 0. Now with this step, you see this now is the leading one, this is the leading one. So the problem is here, we need to make this one 0. So we say row 1 to be row 1, row 2 to be row 2, and then row 3 to be row 3, plus minus 2 row 2. So by doing that, we'll have one, 0, minus 2, 0, 0, 1, 4, 0, 0, 0, 7 plus minus 2. So 7 plus minus 2 times 4, 7 minus 8, which is minus 1. Now we say row 3, row 1 to be row 1, row 2 to be row 2, and then row 3, we say to be row 3 times negative 1, so that we enable this one to be 1. So by that, we'll have our system or our matrix as 1, 0, minus 2, 0, 0, 1, 4, 0, 0, 0, 1, 0. So this is in the row echelon form. Now remember, this corresponds to, this is C1, C2, C3 column. So it's like we have C1 plus minus 2 C3 equals to 0. From this row echelon matrix, so minus 2 C3 equals to 0. And then C2 plus 4 C3 equals to 0. And then C3 equals to 0. Now using back substitution, we have from this C3 is clearly 0, and then C2 plus 4 times 0 equals to 0 implies C2 is also 0, and then C1 minus 2 times 0 equals to 0 implies C1 is also 0. So we are getting C1 equals to C2 equals to C3 equals to 0. Hence, S1 is linearly independent. So whenever you find all the CIs to be 0, then that's mean that the set we're dealing with is linearly independent.